As the next application of linear algebraic equations, let us consider the following electrical system. In this scheme, this rectangle and this one denote a resistor. And this element is a battery, a direct current electric source. Let us denote the voltage at this point U1, the voltage here U2, and the voltage here U3, relative to the ground, which is this pole. Let us denote the voltage of this battery V1 and the voltage of this battery V2. And then the current in this branch, let us denote it I1, and the current here I2, and the current here I3. Then we want to write some equations describing this electrical circuit. This is the Kirchhoffs Law, or if you like, it can be expressed as the conservation of the electric charge. That means in this node we have three currents, I1 going in, I2 going out, and I3 going out. So if we consider all the currents going out, that means I2 plus I3, and because I1 is denoted in this sense, then the current going out is minus I1. And the sum of all the currents going out must be zero, because no electric charge is generated at this node. Well, and then using the Ohms law, we know that the product of the resistance R1 times the current is the change of the voltage, the drop of the voltage U1 minus U2. And similarly for the second resistor, the resistance R2 times the current I2 is the voltage at this resistor, namely U2. Well, and the same for this resistor, R3 times I3 is the voltage U3. And then, if we denote the voltage of this battery, V1, then it is equal to U1. And this voltage is the change of the voltage between U3 and U2. Well, so we have 1, 2, 3, 4, 5, 6 equations for 1, 2, 3, 4, 5, 6 unknowns. And this is a linear system, so we can describe this system of equations by the following augmented matrix. Each row corresponds to one equation, and each column corresponds to coefficients at one unknown. And this is the right-hand side column, which is in most cases 0, but here is V1 and V2. Well, and we have the matrix describing the system, and we can again use the Gaussian elimination and to solve for these 6 unknowns.